Hello and welcome to Cleveland React. Um, we have a pretty exciting meetup here tonight. Very quickly, Cleveland React, we have a code of conduct, so please abide by it. You can find it here. I'm going to put it here in the chat. Just be good people and we'll be okay probably. As usual, Cleveland React we're kind of looking for speakers and events and the planning and everything like that. So if anybody ever would like to speak or has ideas or have things they'd like to learn about, please reach out here or we're on Twitter, we're on Slack. So if you're not already on our Slack, I think this link is still working, but here's a link to the Cleveland Tech Slack and we can get you in there. Cleveland React has a little room in there. And we are on Twitter at Cleveland React. So I don't know, follow us wherever you want, and obviously on Meetup as well. Tonight we are hearing from Kirk Shillingford. Kirk is a professional software developer from the Caribbean who's been trying to be good at writing code for over 5 years. After getting his start in Python and data science, he fell hard for the functional programming space using languages like Elm and F# for front-end development and domain-driven design. And he's currently spending a lot of time spreading the good word of pure functions, TypeScript, and memes on Twitter. And he has I think next week starts at Blissfully, which is a pretty cool service. So he's going to get started on that too, which is pretty exciting. So we're getting him right on the like Kirk Shillingford come up as he's in the Cleveland React thing. So I'm pretty excited about it. I'll drop a couple links to his Twitter and website and all that stuff in the chat. And tonight we're going to be hearing about XState, which is a state management program for React components using finite state machines. Very excited about it. So without any further ado, I'm going to turn it over to Kirk.
Hey, can everyone hear me? Cool.
Yes.
I'm going to try and share my screen, and we're going to jump into this. That's step one. That should be okay. Hide the meeting controls. We're going to hit play. All right, so I can't see anyone. So Dan, you will let me know if anybody has like a question or wants me to repeat something or pause, and I will follow the lead from the sound of the voice.
And feel free to drop questions into chat, anything like that too, if you would prefer, and I will interrupt Kirk at the least opportune moment. We'll go from there.
Yeah, so like Dan said, this is going to be about React and XState. Just for a little bit of context, just before we jump in, XState is a sort of general kind of like finite state machine application in JavaScript and TypeScript. So there's XState React, there's XState Vue, XState Svelte, XState, everything you can think of. There's a lot of bindings there. But so we're going to kind of start with just general XState and then take a look at like how it pairs with React and stuff. I'm going to do a little bit of framing at the beginning, just stuff like why we're doing this, and then just enough context and background of like what we're talking about so that we can dive into some examples and hopefully have some fun with it. Yeah, and I think that part of this is that like when we see React and XState, the first thing I think is like, well, there's another name for a project like this, which is like, okay, we're doing another state management framework with React, which is, sure. There's Redux, there's BobX. Honestly, there's like use reducer and some types. So this is not just to like, well, here's how to do this thing. But I'd like to give you a little bit of context of like, well, why this thing? Why is this a good idea? Why might you want to try it? Why might you not want to try it? I honestly have not spent like my entire, career like working with this library. I'm still fairly new to it, but I figured that could be valuable for people because one of the things I like about React Cleveland and just, meetups like this in general is there's a million things going on in programming, and it's sort of like, you can't learn everything, you know? I'm gonna move away because he looks like bored and he's like freaking me out. But yeah, there's like a million things in programming and we just don't have time to try everything. Like there's so many things I want to try. I don't have time to try Svelte and Nuxt and Next and Jest and all the other things. So I like these times where someone can come in and tell me, hey, here's why I like this. Here's how to get into it. Here's why I think you should try it. And they sort of like do the hard work essentially of like banging their head against it and giving me some insights. So if possible, I would like to do that for you. So consider me, you know, the person doing the heavy lifting of like banging my head against this so I can tell you, hey, what's the best way to dive in? Why might you want to use it? And when's a good time for you to be like, actually, Kirk talked about that. I don't think this is the best time for that. We can pass. I think that sounds good. Okay, so why are we here? Let's just get some context on, you know, who am I and kind of what's going on, what inspired me to talk about this. So brief introduction. That's a picture of me. My name's Kirk Shillingford. That's not me. But I do live on a small island called Dominica. That's where we're at, just a little to the east of like Puerto Rico and the Big Islands. It's a really cool place. If you ever have a chance, you should come visit. Yeah, this is where I've lived for most of my life, except for about 5 years when I lived in New York, which is where I started programming, and I just sort of kept doing it, and it's been pretty fun. Like Dan said, I have a mild obsession with functional programming. It's just something I think about a lot, and I write about it, and I read about it, and I dream about it. It started with Elm. Elm was actually how I got into front-end development after kind of not getting it for a long time. And then that became F# on the .NET stack and a little bit of Haskell. But I mean, in addition to those, I've also done some work with a lot of other languages. Python was basically how I got my start in programming. I've done a lot of work with SQL, and most recently TypeScript. You know, and I'm a little different than most people. TypeScript is how I got into the JavaScript ecosystem in a weird way, which I don't know if is a good idea. It's probably not, but I like TypeScript, and it's sort of transferred over into being enjoying JavaScript more as well. So I think that's pretty cool. Yeah, so all this to sort of say, you know, like I've written a decent amount of code in my time. I don't think I'm like an expert by any means, but it is something that I like to do and I do for a living, and I think it's pretty fun. So a lot of time reading code as well, and this sort of like gets into why we're doing this talk. After reading a ton of code, I feel like there's a sort of pressing question that I basically have, which is sort of how do you like write good, readable, resilient code? And I think like the whole reason why we're in this meetup group is to try and find like better ways of doing this. And even more important than maybe like writing code for yourself is how do you get like people, like other people, to understand the purpose and the logic of your code? And I don't know if it's just me, but you know, I can look at someone else's function and I get it. You know, I can look at someone's class and probably get it. I can look at a module or a single file and get it. But like once it gets beyond that, I struggle to understand. You know, I hear people say things like, "Oh yeah, that guy or this project has like a really readable code base," and I'm just like, I don't. What is that? I don't even know what that means. I've never been able to sort of like quickly understand like an entire code base of sufficient complexity. And I don't necessarily think that that's something unique to me. It feels like a common problem, and I would go so far as to say that, you know, understanding an entire code base is hard, you know? And I guess I'm going to kind of make a bold claim. This isn't Twitter, but like we can do a hot take on why that is. And I would say that it is because like code doesn't scale. just as an application grows, I don't think that just reading the code is the quickest, most reasonable way to kind of like grok what's going on. So what might the answer be? I guess we can kind of get into that, right? Read the docs. Hear that a lot. Hey, just like read the docs. Hey man, just take a look at the documentation. So then like the response, like, well, what documentation, right? Like theoretically good, but like ultimately it feels very difficult for getting a holistic understanding of the system just from the docs. You typically require a ton of docs. Everybody has like different ways that they understand. So you not only need documentation, you also need examples. You also have to make sure the docs are up to date. And if it's a growing, changing interface, very frequently the docs lag behind the actual product. And, I've also noticed that it's one thing if you're looking at sort of like an open source library or something like that, but like when you're joining a team, the type of docs that you sort of see in the wild or in these like big things like React are not the type of docs you see internally. So this is a kind of a hit or miss thing for me. It's just doesn't always satisfy that need. What about UML? For those who are not aware, UML, Unified Modeling Language, is basically a visualization tool created for examining like code objects. And when people bring up UML, I usually say like, well, like, what about UML? Like I don't actually have a big issue with UML, but UML is designed for like enterprise level object-oriented systems, and I don't actually think it's very appropriate for languages like JavaScript with first-class functions or declarative frameworks like React, which already have like better solutions. Like this is great for understanding the objects in a code base, but it's very hard for me to watch this and understand what is going on. That sort of high level picture that I'm looking for really isn't satisfied by something like this. It just looks like boxes and arrows. So not a huge fan of UML. So what do we do, right? If the code doesn't work, the docs don't seem to always work, UML doesn't work, do we have a more suitable medium for communicating code like purpose and intent? Not what the code is, but like what does it do and like how are we doing it in a way that somebody who's new can take a look and just have more context for what's going on. I think there's an answer to that. Math, not math. Logic or finite state machines. Finite state machines were invented by mathematicians, but I don't typically like to call it math. I feel like that implies certain things that a lot of people are not necessarily comfortable with. And it's really not a place of like numbers or equations. So I prefer to just call it logic. Logical systems that deal with how applications change over time rather than static structures that say like what an application is at a specific time. And we're just going to kind of like dive right in and learn about that. Part two, what is state? What are state machines? What are state charts? State is this like phrase that we use very often. And we sort of like especially bandy it around nowadays in the front end programming space, especially with frameworks like React and Vue and these state management tools. But I feel like there was a time before where people didn't really say the phrase state that explicitly. It was just like this thing that it was just kind of implied. But we have like more declarative systems now where you have to be explicit about state, which I think is a good thing. But like what's actually going on there? Program state essentially is all the variables in a program and their values at any point in time, right? What differentiates state from like everything else in your code is that at one point in time, it's set to this, and later on down the line, it could be something else. You have some counter, it starts at 1, later on it could be 3 or 4. You have some piece of data, it starts off null or empty, and then later on it might have values in it. If it changes over time, that is part of your application state. And I feel like it's worth taking the time to kind of like think about that statement, because there's a lot of things in even small code bases that change over time, that we sort of think, well, that's not in my like React object, or like that's not in like my MobX DOM tree, so that's not part of my state. But like, it's all part of your state, right? It's just like, you can either be explicit about it or not. But if it changes, it's a part of your application state, and it's something that in some way or another, you have to manage. And that lets us transition to the next thing, which is, what is a state machine? And let's just take a look at sort of like the simplest possible example of state machine. State machine, or an abstract machine, is just something that can be in any number of states, but only one at a time. And this is kind of like a key thing about like a finite state machine. This is the classic example of your application is just like a door, or like a door can either be opened or closed. Those are the two states of the door. The door is either opened or closed. If the door is closed, there is one transition that can occur. That's an open event. It can change to open. If it's open, there's one event that can occur. Closed, it changes it back to closed. So state machines are just these two entities, essentially. What are the states that your application can be in? What are the transitions or events that can occur in that state? Yeah, this is just like what I said, sort of refined and better. One state to another in response to some external input. This is called a transition. The transition. All state machines have an initial state and the conditions for the transition. So this one doesn't say it here explicitly, but oh yeah, it's like the state machine has to start somewhere. You know, like you have to tell like what state is like where you get into the machine. And once you get in, you define how do you transition from one machine to another. So state machine, it's an alternative way, right, of talking about the way our programs work. We're not defining independent variables. We're not defining like looking at like the interaction of static objects. We're just looking at what's possible when, and how do we get from what's possible to what is also possible, right? Like start from a valid place. Something happens, it takes me to another place. Something happens, it takes me to another place. And if an event is not defined on a state, well, then that like your state machine can't do that transition, right? If there's no event to join two states, you can't go from one to the other. And it turns out like most of the things we interact with in life operate implicitly in sort of like state machines. Another classic example are things like gumball machines or vending machines, right? Like you don't just like get the thing out at any point in time. It's like, oh, well, you have to pick a number, and that changes you to the state where like, oh, okay, a code has been picked, and then you have to enter the right amount of change, and that's the condition for the event. And if those things happen, then you can transition to like the candy released state. And that's your final state, and it ends, and you can kind of like do that loop again. But you can't go from just punched in the number to getting the candy out. That's an invalid state transition. Please let me know if I'm talking too fast. I feel like I'm talking very fast. And that's really all finite state machines are. This is a mathematical concept that's been around for like 60 or 70 years, you know, and we can sort of like define them more and get more abstract about it, but I don't actually think that's very necessary for developers. We basically just like need to know what they are and that they exist. We also need to know that there is sort of a flaw to the state machine that I just showed you, that standard state machine. State machines can suffer from what is known as state explosion, which is more scary than it really should be. This is like a simple example. So initially, let's say you had some button or some element that was valid or invalid. It's like, okay, cool, I have two states that can go from one to the other. But what if it could also be enabled and disabled? So it's like you have this axis of these two things, and this axis of these two things. So now you have four states that could be valid enabled, invalid enabled, valid disabled, invalid disabled, right? And let's say we added another thing that it could be. Now we have like 8 states, right? Because it's like all of these plus this new thing. So you can see like that could very quickly blow up. So much so that when people originally conceived finite state machines, they realized this was a problem. It's like, well, maybe we need a even better way to describe our applications in a way that doesn't like exponentially explode once things start getting more complex. And that is where we get to the humble state chart. State chart is sort of some people call it the bigger brother of the state machine, or the more evolved version of the state machine. And state charts are the same basic concept, but with like a couple extra features to make things a lot easier. The main thing is like state charts allow for nested states, so states within states. So here we have like interaction with a form. You start with the empty form, there's a submit event, you can go to submitting. And from submitting, you can either like reject or resolve. But notice that takes you to this sort of super state that inside has its own other states, right? So you can take like what would have been a big blow up if these had all been independent and sort of collapse them. You can keep collapsing states and collapsing states, so it's always manageable. State charts also allow for historical states, states in parallel, and they basically like solve the issue of the like more rudimentary state machine. So when we talk about like finite state machines for modeling in JavaScript, people are really talking about state charts. And the library we're going to see, XState. XState is an example of a state chart modeling library, not necessarily just a state machine modeling library, because real applications are complicated and just state machines would not really do the job. Let's see. So just to kind of summarize this, what I've been talking about for just a little bit here. It's difficult to understand non-trivial code at scale. The usual tool set does not seem to provide the appropriate amount of clarity. Finite state machines in general, and state machines and state charts in particular, may be a better way of teaching, visualizing, explaining, and writing the code. And honestly, that's the end of the slides portion of this. After this, I'm just gonna like jump into some practical examples. But before I do, just a quick pause here if there are any questions at this point.
Excuse me. I was going to say, and it's possible you're just like planning on still getting to this and stuff, but because of the sort of different approach to creating, state machines and that sort of thing, are there certain cases where, are there common ways where you would decide to use state machine versus just using, whatever, like using Redux or using just like use state or that sort of thing? Are there like situations or, like a code smell kind of thing where you're like, okay, this is going to be perfect for a state machine, or like, oh, this is going to be not perfect? You know what I mean?
Yeah.
But like approach wise, when do you start reaching for that? Is it early, or is it, that's just a general question. So, it's okay if there's
yeah. No, I think that's a great question. We can talk about it now. You should always do it. That's not true. First of all, it is a state management system, right? If your state does not feel complex enough that you want a state management system, like in the same way, like, like, okay, this is a little too, I don't need Redux for this. If you don't need Redux for something, you probably don't need XState for it either. I think it's like the simple answer. If you just went with, and we'll kind of see as we get into this, I think there's a couple advantages to XState that go beyond just like using it as a state management tool. And being honest, I don't think it's like that much better if you're just using it as a state management tool. I think the real power is as a state management tool / documentation tool / teaching tool. But I feel like it really, the more complex your application is, the better XState scales, for sure. So if you're doing like if you have like a single like fetch request, you probably don't need XState. You definitely don't need it. But as soon as things on the front end start getting more complicated, as soon as you start getting different types of requests and you see the app growing in complexity, it's a better and better case for getting into this. And that isn't to say you can't use it for simple things. I kind of like using it for simple things because as we get into it, you'll see how like XState kind of forces you to think about an app in a way that will kind of keep you, I think, in a safe place and sort of reduce some of the confusion I find like when I'm teaching people about how to model applications, especially newer people, because like we see all these words like state and effects and like responses, and people start to be like, it's hard for you to understand like where does this all fit in, and XState's like, hey, here's a blueprint for how that fits in. But yeah, I would say save it for the really complex stuff, or if it's getting complex, go for it. Okay, taking a brief, just gonna look at the chat. Okay, cool. Dan's complaining about math. Mike agrees. Awesome. Okay, so I'm gonna do a new share. And if that works, you should see my Chrome browser. I'm just gonna kind of dive right into it. Can everyone see that?
Yeah, I see Chrome and
yeah, you should just see like Google Chrome and a bunch of tabs. Cool. Cool. So now we're basically going to do a walkthrough of an implementation of a state chart library, which is XState. There are others. There's a couple. I know there's one in Python. A lot of the languages have it, but this is a React meetup, so we're looking at XState. And I think XState is actually like a pretty cool one. It's cool enough that a lot of the others were created because of XState. So, it's definitely worth checking out. This is the main code base. It's open source. Some of you may know this gentleman who goes by David K. Piano. I'm pretty sure Piano is not his last name. His real last name is Khurshid. But he's been the sort of major contributor to XState, the major proponent of XState, major proponent of state charts in general in the JS and TS ecosystem. Very, very awesome guy. XState is used by about 65,000. Well, it says 65,000. So like it's in that strange way in software, like just because something is the less popular thing doesn't mean it's an unpopular thing. What I've liked so far about the XState community is they're really into it. It kind of reminds me of the same energy I get from a lot of the Rust people and a lot of the Elm people. They definitely enjoy using it, which, I mean, I don't know how relevant that is, but it's just like, for every one person I hear like complain about Redux, I hear people like say, oh, I really like XState, but I haven't like gotten into like the whys or like the psychology of that. But yeah, it's got a pretty active community, which I wasn't surprised that people were into it, but I was surprised by how many people and how enthusiastic they were about it. So it's definitely been like a fun space to be in, which I actually think is really important when you're asking people to learn new things. We've all had that feeling where we've kind of gotten into something, but like the ecosystem has felt very stale, and you're just like, I don't know if this is going to continue. I don't know if this is something I should spend my time on, but it's always in different stages of development. They're always pushing out changes. I think the most recent, like release was like a couple of weeks ago. And it's very, very cool. So yeah, there is XState for React, a binding for Vue, for Svelte. It has its own test framework, has its own inspection framework. They're trying very hard to have decent documentation. So every template that you could think of, quick starts, and just as much examples as possible. And I know like David and like the group that he works with are trying to make it even better. So I will say it hasn't been a perfect experience kind of learning it the way I have and as quickly as I have, but it's definitely been like better than most, I think. And what I really like is that there's just a ton of examples, which I always appreciate. And what we're basically going to do is we're kind of just going to go through some of the examples because I think they're just a great way to figure out like what's going on. Cool. This is sort of the simplest, or one of the simplest things we could look at in XState that sort of represents something we do a lot, which is doing a fetch request. So here's the actual, this is the actual code that you would write, or you could write for a state machine here. And this is the state chart visualization that comes from that code. And Dan, earlier on, you asked like, well, why would I use XState? Or like, what's a good time to use XState? The fact this visualizer, I feel like was the tipping point for why I decided to do this talk. Because it's one thing to tell someone like, hey, I can walk you through this code, which is essentially just a JavaScript object. But showing someone something like this and walking them through this, like I don't even need the code, right? Like here, okay, so let's just like go through it now. This is a simple state machine. This lets you know your initial state. We start off in idle. There's one event on idle, that's fetch. If you trigger that event, you go to a loading state. And the way the visualizer works is it shows you what state you're in and what are the possible transitions from that state. So we're loading. It can either like be resolved and we get a success. This double outline means it's a final state. This is where the state machine will end and exit. Or if you hit reject, you go to the failure state and hey, there's a retry event, takes you back to the loading state. I really like this. I like this as living documentation. If I have this in my docs, like I don't have to worry about has the diagram gone stale because the diagram literally is the code. You know, so as the code changes, this will update. I think it's a great way of explaining the flow of an application. This is obviously a simple example, but these can obviously get more complex. You could build in the promise async await structure into this. And again, it's just like this visual way for someone who's learning or someone who's trying to understand like what does this code do to see it as it like travels over time, you know, and you can follow the path of the application as things happen. And I think that's really valuable. So this comes with using XState. You have access to the visualizer. And in the same way that you can set up a live dev environment that changes as you make changes, you can set up a live visualizer. So as you make change to your code for your state machine, the visualizer changes. And it's just like it's like a feedback loop. So you can like, hey, if I did this right, then the visualizer, like I should be able to see what I wanted to represent in the visualizer. And I think that's super powerful, you know? I think the big thing nowadays, especially in front-end programming, is having ways to see your application or what you're working on that are not code. You know, React has things like Storybook and a couple other frameworks for working on things, but not necessarily like playing around in specifically JavaScript or TypeScript. I think this does that, but for the application level. And the important thing to see here is that like this is UI independent, right? This is, you can layer this on anything you want. You don't even have to layer this on React. Like you could just write some elements to match up. It just tells you, hey, what state of mind, what's going on. A brief look at the code. So you just define a machine and you basically pass it in an object defining like what are the parameters of that machine. So the ID, which is important if you have multiple machines, but basically like initial, what is our initial state? What is the context associated with that state? Which is like what data is associated with this state? And then the states themselves. So we have an idle state, a loading state, a success, and a failure. And for each one, we can define what are the events that are associated and where do they take us. So if you're in the idle state, on the fetch event, go to loading. If you're in the loading state, on a resolve, go to success. On a reject, go to failure. If you're in success, it's the final state, you don't go anywhere. And here you see, if you're in the failure state, there's a retry event, the target is loading, and this action lets you update the context. So go to loading and update the context, and that's how this whole thing works. You feed it into the machine, and it's gonna produce an object that basically only lets you transition to what you declared as valid. You can engage a fetch event if you're not in the idle state. Like it will not perform the transition because it's the wrong event for that state. So once you've made the state machine, it is impossible to trigger an event that should not occur in the state that you are in. And going back to what is the difference of this versus something like Redux or some of the other state management things? Many of them let you define what are the valid states of your application. Not as many of them provide what I feel like is this sort of interface for saying, when can you go to the different valid states of your application? Or you kind of have to handle that yourself using like a reducer or some sort of like function that does that routing. But ultimately, that's just the function. Like it only works correctly if you tell it like to do the right thing. And it's easy to make mistakes. Whereas here, once this is baked in, it will, you can't go to the wrong place from the wrong event. So I think that's pretty cool. Clearly, let's take a look at another one. Okay, so this is one of their examples they provided. So this is like a authentication flow, and a good way to think about these is XState and state charts allow you to like define the flow of your application in a way that like turns into real code. So we start off at our initial state, hey, check if logged in. If you're logged in, you can go to the logged in state. And from there, the only thing you can do is log out. And log out, you can only go back to log in. If you had an error, it would take you straight to log out and you kind of do it again. Here on the side, it's like, well, this is what is happening in my state at the time. What state am I in? What's the context? What event brought me here? You can get these from the inspect library and some of the tooling. You know, you have the time traveling debugger, so you can see all the events, right? Because these states and events are not implicit. There's always a state and there's always an event that brought you to that state, so you keep track of those. And you can see like the sequence of states that you've been in. So this is just like a simple example of that type of data flow. And here, there's some details on what functions are running for these things to happen. So one of the things that the state machine doesn't define, right? You can say the event, it doesn't really like constrain you to how that event like takes place. So some events involve an external request, some of them maybe just like a transition within the code, and that's fine. It's just like, what's the valid state? What's the valid state from there? I think that's super cool. This is another data fetch. So again, we start in this idle state, and notice there's a substate here of no error. This is how you enter your application. We can do a fetch event. That takes us to fetching, and then we have options, right? Did we get the data? Did we cancel it? Did we do a new fetch? If we received it, cool, we're back in this idle no error state. Let's say we did the fetch and there was an error. Now we're back in idle, but now we're in this error state, which is, you know, these are all things that we do all the time in our applications, but we sort of do them implicitly, or like we know we have to do them, and so we find some way to write them in. XState is just a way that like lets you clearly say like, oh, well, this is what's happening. And once you set it, the state machine will kind of handle making sure that like you do the right thing. Let's see what other examples I have here. I just have a couple of these. I think we did this one already, so we don't have to jump into that. Cool. So this is their documentation, or one of their documentation stubs, which I've been using extensively. We've got a lot of docs, a lot of guides on everything defined here. So they actually invented a XState like XML. There's like a state charts like XML schema defined. So all these things are completely like defined in like a specific XML schema. So what's happening under the hood is these diagrams, XState will generate the XML. The XML can be turned into a diagram. And that is like a well-defined lingua franca. So everybody who's writing state charts are all like using the same language. So if you can read XState's state chart syntax, you can read all the other state machine library syntax, because they all do the same thing and they all like work the same way under the hood. So that's also super powerful. What else did I want to show you here? And yeah, so the last thing I want to show these here. So far we've just been looking at like the state chart and just the state machine. the last thing I just want to show is like actually using it with React and how you just sort of plug that in. So this is to do MVC, but using XState, and it's actually pretty straightforward. So you're going to need the XState library and the XState, like sort of, well, you don't really need the inspector. The inspector just gets you the state chart. Here. There we go. And there is the connecting library, XState React. Just get that in there. And it's pretty simple and pretty like, it's similar to the way I guess you'd sort of use your use state, right? So instead of use state, you're either using use machine or use actor. For those of you who are familiar with the actor model, XState like supports that pretty well. So you can define all your different states as just like separate actors who think independently and pass messages to each other, which is basically how this to-do application is working. And in almost every XState library, you'll just see like one file, which is our machines. And yeah, it's the same structure we saw before with just a little more complexity. Our initial state is reading. We have more context, an ID, a title, a previous title. You can toggle complete, you can delete, and it's just, we're just defining JS objects. So this person chose to do this all in one big object, but if at any point it gets too complex, you can just break out that field and store that somewhere else. So you get that sort of composition, and componentization is not a word, but in the same way that when your app state gets too big, you separate it into multiple modules. That's super easy to do here because ultimately these are just like JS objects and fields. And for this one, this is, it also like generates the state chart as well. So when we open up this project, because it uses the inspector generates the state chart for this object. And that's great. You know, so like whenever you're working on an application, if you want to, or if you choose to, you can just have the state chart running and understanding what you're doing. And again, this is the type of thing that just feels better for onboarding new people and telling them about the code than just like saying, hey, yeah, just like dive into the code base. You know, like I don't know what the code base is doing. So I like starting with people's state charts, understanding what their application is trying to do. And then when I have that context, okay, now I can look at the code because I just kind of get what's going on. What's another cool one? State chart driven calculator. This one is even more complex, but again, it's the same context. I really want to talk about this, which is conditional actions. So sometimes an event might trigger multiple actions. Sometimes you might need to do a branching condition. Then it's just like, that's really easy because what's the condition for this action? If it's satisfied, what's our target? And then what do we actually do? So a event might trigger multiple things. Well, there's a syntax for defining that. An event might have many places you can go. There's a syntax for defining that. An event might occur in multiple, the same event might happen in multiple states, like that's okay. And XState will always work from the smallest substate out. So you always know the order of operations for what's going to happen when an event occurs. You start all the way deep and then you work your way back to the major state. But notice here, I think I also want to point out just like the shape of pretty much every XState project, there's a similarity there. At some point, you define your machine or machines that define how that thing works. That's your source of truth. That is your application. React is just this thing that says, okay, I am going to just essentially like plug in to that working state machine. And wait, jump here. There we go. React just says, I'm going to plug into that state machine and I'm going to use what it defines as the state that's going on. to define like what I'm going to do. So right here, instead of where you normally say like use state, you're just saying use machine, and state and send machine are pretty much the exact equivalent of state and the like set state events that we usually use in React. So like if you're used to React and any type of state management, it works pretty much the same way. The last thing I'll show you is like the little bit of advantage you get with TypeScript, but I actually will say this is one of the libraries where I don't even think TypeScript is like, I like TypeScript obviously, but you're getting about as much power to me from JavaScript and XState, and like TypeScript is giving me a little bit more, but it's not that much more. So, you know, if like I had a choice between TypeScript and JavaScript, I would take TypeScript, I think. But if like I had a choice between like TypeScript with like no safeguards and JavaScript with XState, I might go like JavaScript with XState, just because like XState is providing so much like safety and security on the front end side. So I feel like that's also like pretty cool. But yeah, this was like the key thing for me getting into it. The fact that once you set it all up, actually using it in your React app basically follows all the same principles. You just swap out, you know, your regular stuff for this, and that's really good. Yeah, let's see. There's a COVID tracker, but I guess the last thing I want to show you is the application that I made to teach myself this library, and hopefully to show some stuff to you too. The UI is not great. I asked Dan for some help, like way too late, so it's still not the best, but thank you, Dan, for trying to help me with it. So basically tried to make a Minesweeper clone using React and XState. I'm going to clear this console, if it will let me. And I'm going to refresh this. And what I've done with this one is I've just added a console.log to show you what is the context of the state at any given time. I don't want the inspector right now, though. That's okay. And we're going to wait for Code Sandbox to load. I did this entire project in Code Sandbox, and that was maybe a mistake. It gets very slow after a while, but I just like the portability. Okay, cool. So here you see we have this one piece of context, which is just the size. And of course, every time we do this, it's updating and the size is changing. I'm going to hit, well, actually, let's go back to 3. When I hit start game, we've transitioned to a new state with new context. So now we have both size and duration. So normally events are instantaneous, but you can also have subscriptions. So you can have it subscribe and like send an event at every interval. So basically we're sending a tick event to our state machine, and that's happening every second, and it's just set interval. And like there's a nice way to bake that in. If we click here, well, we have our third state transition. The weird thing about Minesweeper is that like you can't start playing the game until after the first cell has been clicked, because you never want the first click to be a bomb. So you have to wait for the person to click a cell, then generate a valid grid, then actually get into the game. So we could just model that here. So when we clicked new state transition, now we have more context. We can keep playing the game. I may lose this game. We'll see. Maybe this is not a bomb. Okay, that was not a bomb. That's pretty good. Okay, never mind. I messed up. Yeah, and last event, there's a condition here. I lost the game, and it stops, and that's kind of like just like the whole thing. But let's quickly take a look at the actual code as soon as I can get my browser to stop freaking out. Okay, so I just want to walk you through this last example. Yeah, so up here, this is very much just regular React with a little bit of Bootstrap, which I was testing out. So here you see these send events. Send is part of the state machine like syntax. Send is basically just like what you use to send some type of event and its payload. So every time we click a cell, we're sending this type of event and with this position. And down here in our main, what we've done is say, okay, current is the current state of our state machine. Send is what we're going to use to send events. And we can basically do a match on what the state is. So if we're in the pregame state, then this is what we're returning. If we're in the active game, if we're in the end game, and we're basically just like doing an if statement, you could also do like a switch case statement on this. The powerful thing about XState and TypeScript is with TypeScript, it can match the state you're in to the context associated with that state. So it knows if I'm in endgame, like there's definitely going to be a grid. If I'm in like the start of the game, there's definitely going to be a size. And TypeScript will like give you warnings if you don't satisfy those things. So that's pretty powerful. And just to take a quick look at the state machine itself. Because it's TypeScript, I get to do this fancy stuff. Basically, we can initialize our state machine with like all the values we're going to use. So we define all the events that are happening on it. We also define like all the valid states. So choose size, start the game, click a cell, or the tick event. That's the 4 things. That's the 4 events this application can have. So those are the only things that can trigger changes. And then pre-game, in-game, and end-game are basically the only states that we can be in. And these are the contexts that they have. And this is just like a way that I like to write my, my contexts, just so it's like easier to read. Here we define the application. So, hey, if you're in the initial state, which is pregame, you can choose a size, which takes you right back to pregame, or you can start a game, which takes you to a new state. Here we can say, hey, once you get into the game, start up this basically this like recurring like tick event and just have that keep going. And we can tell it like just do that once you jump in here. You don't need an external event for that. We've transitioned to the state. Let's get that started. If we're in the opening game, when you click a cell, it makes a new grid, gets it all started. But generally in the game, when you click a cell, it does these checks. So every time you do this click cell event, it's like, hey, did you reveal everything that's not a bomb? In which case, go to the win state because you won the game. Did you click a bomb? In which case, go to the lose state because you lost the game. And if not, just update the game state. Our end game has 2 states, win or lose. They don't have any payload, and that's fine. These are the actions associated. And these are our guards or conditions to get us to the right actions. Yeah, and that's basically how you get into it and how you use it. I've been messing around with this for about 2 months now. Well, maybe more like 6 weeks. And I genuinely really enjoy it. It took a while to kind of get used to the syntax, but once I did, it made a lot of sense. I really do like this approach to thinking about applications because it forces you to think about your application. Like, where does this application start? Where is it going? What does it need to get from like one place to the other? Which I think is very, very valuable. And then once you said that in this machine, like you can be sure that the rest of the application kind of has to follow suit. I love how agnostic it is. The state machine itself has no idea that it's in a front-end application or a back-end. Like it really just does its thing, right? And you just layer something else on top of it. And mainly, I just really like the visualization. I like the fact that my code, like I don't have to show people my code. I can show them the state charts instead. I can show that to a product manager. I can show that to a designer. I can show that to a client. We can sit. Something I like doing a lot is sitting with clients and talking through state with them. Hey, how does this thing start? Where does this thing go? Like, what are the different values? And I will sit and I will write that down with a pen and paper. And then I can take it, bring it back, and turn it into code and then get the chart back out. And I can show them the state chart and be like, hey, is this the thing that we talked about? And they will tell me, actually, you can't go to here from here. Actually, that's not a good thing. And, you know, again, like that's the thing I've, you know, you sort of implicitly do with clients, the more you sort of like are into this line of work. But I just like the fact that it's baked into a library and a framework, and it just feels really fun. So pros of XState. Mathematically sound, love the visualization, love it for teaching, for learning, for explaining, for context. Not that hard to get into, although I will say there were a couple places where I got stuck, but when I did, I just like found an example that did what I wanted and worked with it. Also, the community is very large and very friendly. There's a very active like helper culture in the XState community, so I could always jump in the Discord, ask a question, and get a response, which felt really, really good. Cons of XState, I would just say it's another thing to learn, and in a lot of ways, this is like a whole little mini DSL for thinking about like applications. So there is a bandwidth thing there, and it may be overkill for smaller apps. But I tend to feel like that applies to pretty much all the state management libraries, you know. Yeah, that's kind of the gist of it. So I'm gonna stop talking for a little bit, and if anyone has any questions and comments, go for it.
Yeah, that was great. That was great, Kirk. Yeah, does anybody have any questions? I had a couple, but I figured we'll let some people give some people a chance. One of the things I was wondering, I mean, feel free to jump in if anybody has some. One of the questions I had was how XState, how you use XState, how it integrates with effects, with side effects, and like the things that happen with side effects, you know, for instance.
Yes.
So the managing the state of loading an API request, for instance,
Mm-hmm.
you know, like, excuse me, the whatever the state of that thing is, that makes sense. But you know, what do you do with it? Like, where does that data go, for instance? Like, how do you react to? I suppose aside, I mean, you can always use effect, I guess, based on the current state, but I don't know.
Yeah.
generally XState plus you know, side effects. What was the general approach?
I mean, I think that it's in a lot of ways. I feel like it's. I mean, I'm still learning, so maybe there's a better way. But part of me, it's a little looser than I'm comfortable with. But I'm coming from Elm, like it's as strict as possible. So let's say you like need to do a fetch request, right? Like you would be in some state where like, okay, it's valid to do that. You would have an event that says that's what we're going to do. And then part of that event's actions, like here, you would say like, oh, one of the things you need to do is like actually perform this fetch request. So you would define it here, and it'd be like left to you sort of like later on how that's working. Like XState doesn't really constrain you on where the data is coming from, but you do have to be very explicit on like what it can go into and like what's the shape of it, you know? So these assign methods here, basically for updating context, they always take two values, the current context and like some event. So that event could be from an external source. Well, that event is like whatever like event has been fired. Current is context. The context is the current context. In here, you might need to get it from an external API, or you might not. It might just be all inbuilt stuff. XState doesn't really like limit you there. Although I will say, there's a couple more features that I haven't used with it. Like this invoke service is typically a way that a lot of people set that up. There's also the context of like services, where if you need to subscribe to something and have it run in the background. So it has the language for managing it. But if you want, like, it's not gonna like, I don't think there's a way for you to tell XState, oh, I don't want you to be doing any like external events in this state necessarily, because like they're by definition like outside of like XState's purview. It's just that, like if you want anything to enter into the machine, you have to be very clear about like what's coming in, where it's coming from, and where it's going. I don't know. I don't think that's like the clearest answer, but it's essentially there's tools for managing it, but it's not like a rigid set in stone. You can only do this here or here. And let's see. I think, okay, I might have closed that page, but there's a pretty lengthy section in the docs that like goes over it as well.
I guess that's to be expected.
Yeah. I was kind of surprised at like how much it's like, hey, you know, you tell me where this is coming from, and I'll trust you. It's like you can't violate the sanctity of the state machine, but like outside of that, you know, I'm not gonna tell you like what to do with your life, man. It's very Jeff Bridges about it.
Is it, to clarify my understanding, is it somewhat like interchangeable with use reducer, like how use reducer, you know, gives you the state and dispatch,
Yeah.
and you could pass dispatch into more nested components. Like this, you could pass send into more nested components.
It is, yeah, I think it's thematically very similar to use reducer, and I'm like a big fan of use reducer. So yeah, that idea of, hey, there's where we're at, there's something that happened, and I can give you like a new place that we're at. It does have that, but I guess the difference with use reducer is ultimately what's deciding like what's valid and what's not is just that like use reducer function. Like it's just a function. So you could tell use reducer, hey, go from the loading state like straight to error, and like it wouldn't tell you anything because like those are valid states that it could be in. With this, you're defining that at sort of like the shape of the data level, and then the resulting object and methods that come out will handle that for you. So, you know, later on, like if I was in idle and I tried to like send a retry event, like it would just, you can tell it like either I want you to ignore this or I want you to throw an error, because like that doesn't make sense in the state machine.
So yeah, this would another way of putting that be that this is more declarative than use reducer, because
Yes.
like there you have to imperatively define like what the steps are.
Yeah.
Here you're more declaratively defining it.
Yeah, I think that's a great way of like doing that contrast for sure.
Yeah.
And I like use reducer.
Yeah, I was going to say this actually works out. The way the places and the spots you can use it can be very similar too, as opposed to Redux that needs to be all the way on the top of the tree, etc. Use reducer you can use way down low, and yeah, you can pass dispatch a little further down, but it doesn't use reducer doesn't need to be all the way on the top of the tree. And same with XState. You can kind of put in some state machines just in some subcomponents and kind of get them rolling there. It's pretty cool.
Yeah. If you have a relatively simple application, but like one piece that's like really, really finicky, you are 100% allowed to like make a little state machine for that part. And yeah, you just use it like a use state hook, and the rest of the application doesn't have to care at all, you know? So I do like that granularity, and like even this, keeping it as like one big state machine is not something you necessarily have to do. You can spread it out or chunk it up, and it has the ability to declare like parallel states. So you can have like, oh, well, there's this big machine, but it's really just like these very, very much independent things that are happening all at the same time. So it's not like everything has to like weave together. So it's like, hey, I made this machine. So I think like a good example for that is very frequently in applications, we have like some sort of like top level stuff that's there all the time. And we have some like page specific stuff that's very, very contextual. So if you want to model the entire thing as a state machine, you have that top level machine that's like always on, and then the page stuff is where you're actually like doing all the transitions. That could be perfectly fine.
And for generating the visualizations, like from your development environment, is there like a command to launch a local server that shows that stuff, or how does that work?
That I've only poked around with a little bit. It's actually been kind of, there's been a couple of times where like I didn't want it to do it, but it tries to do it anyway. It seems like if you step one is getting the XState inspect library installed, and I haven't dived into configuration, but I think it's pretty light setup. Like if you've got it running, if you run the inspector and it finds a state machine object in your like a code tree, it will just try and spin that up. But I don't have too much details on that yet. I think that's like the next place I want to install, explore, because I was trying to get it to work without the state chart first of all, and it just keeps trying to make a state chart. I also do know, I talked to David about it, and he said like one of the limitations right now is XState is written at this point like completely in TypeScript, but the visualizer still has trouble with TypeScript. I think it still prefers JavaScript. And what they're working on right now is getting it to go in the reverse. So giving people the ability to use the chart and like a sort of like a drag and drop UI to make the shape and then have that spit out the actual like code object for you to use. But yeah, I'm still getting used to the visualizer. I just like know that it's there and that it's pretty cool.
Ian, did you have a question? I saw you kind of unmute for a little while ago. So
Yeah, I was toggling on and off there. I was sort of wondering, can you just like provide the state machine to components lower in the tree via context if you wanted to like share the state machine's context?
Yes, I think I do that here because there were a couple ways I could model this one, and what I ended up doing was not passing the entire machine, but I did take like the send object, which is like very similar to like dispatch, right? Just like providing a hook. So like, because only the cells really need the send object once the game is going. So yeah, you're free to like shoot it down as deep or as high as you need it to. Ultimately, it's just gonna spit out like, oh, I went too far. Use machine is going to provide you with this single object that lets you match on states and get the context out of the states. And then this object, which can send some event back to it. And like you can inject this anywhere that you need to. It won't affect like the machine itself. So the machine is always okay, you know?
The machine is always okay.
Yeah, well, the machine is always what you said it should be. So if you said it should be fine, then it's fine. If you messed up, then like it's okay. But I find like what I do appreciate is the language I think is pretty clear once you adjust to it. Maybe Becca is here. So, you know, at first this was kind of annoying to read, and I will say I don't know how I feel about like big objects like this, but it's like, okay, these are my states, I know what on means, I know what these are, like you start the syntax becomes like pretty straightforward at a certain point, and they start to get a lot easier to understand. My big issue is just that when people write them out like this without breaking it up, it's just like nested object hell, because I'm like, are these things on the same, you know what I mean? Am I at the same level of nesting or not? But that's not really an XState problem. That's just like a don't make your JS objects too deep problem.
Well, and you could, I mean, you know, you could break them up, right? It's just just an object, right? So, I mean, I don't know if anybody ever does that. Maybe XState purists would, you know, get up in arms about it. But like,
people
I totally
definitely do.
Like just a, you know, machine file that has a bunch of different objects, or even different files if you really wanted to do
Yeah.
that. And then just say, oh, here's the pregame one, here's pregame object, and etc.
A lot of the examples do it as like multiple machines. And I know with the new version, it's like for these sort of like, especially these like invocations, it's like, well, you can give it another machine, you can give it some sort of like event object, you can give it a data stream. Like it gives you a lot of ways to just like plug some like source of context in, and it'll just work with it. So I think, I don't know, shout out to David. I think he's done like a pretty good job with like making the library sensible, but like still keeping the rigor that you want from it in the first place. So like every time I'm like, oh, I wish there was like a convenient way to do this. Like I'd go back to the docs, like, oh, actually there is a convenient way to do that. He already thought of that.
I love that. I love that experience.
Yes. I wish this was easier. Oh, this actually is easier. I was wrong. Great.
Yeah, and the fact that it's actually has gotten away to the docs and isn't just buried in some GitHub issue or something, somebody else comment. I'm putting David's Twitter here in the chat because he's a good follow if you're into React and just into a lot of things. But
yeah, I think this is his full-time thing now. He's just like always cool. On. So last thing I wanted to show. Yeah, just to kind of go over again, like what's in here. So the concept, so there's like a lot of, if you want to go through like the formal what machines are, because this all started because you told me to check out like David Pano, and then he had this tweet like, hey, you should read this paper about like finite state machines. And then I did. I read this 56-page paper about finite state machines, and like it's just a math paper. It's not even program, it's just a math paper. And I was so mad.
Mad because I was right though, right?
Whatever, man.
Because, yeah.
But yeah, but I really do. So like there's a lot of these here, and actually this is not what I was trying to look for. There's a library. Actually, I think I know where to get up to find it. They have a page that's just recipes. Like it's just like little XState examples, and it covers like all the things or most of the things you do in front end development. Like fetching requests. Okay, this is not where I want. I'll send you the link after, and you can find it. But that's where I got like a lot of these. Right, Kirk was right here. The XState catalog. So yeah, it's like, hey, form inputs, multi-step forms, validation, and they're always adding stuff, timers, queues. So, it's like, hey, if you want to use this, like I really appreciate this a lot. And this kind of goes back to the documentation is like frequently not enough. They're trying very hard to provide enough docs. And I think that's like a very noble endeavor. One of the issues I do sort of have with the React docs right now, and I mean, the React team is great, but I just wish there were more official examples, especially of like using different hooks in combination. So, that is another thing I like about this. There's a lot of examples of like, oh, well, okay, here's how we use like conditions and invoke, or like services and, like how do you put this together? So that's really good.
Yeah, that's so cool. I just put this in the chat, but that the recipes, like that concept for docs and for learning and for reference almost, is such a useful thing, because that's always what you want to do. Once you learn like the basics, you're like, okay, man, how do I do this? How do I do a form? How do I do a select drop down or whatever in X?
But yeah, I would say like if you're actually trying to use a library, then you are already in a problem domain that is like already not in an example, right? Like because people make it like like when I want to do this with Minesweeper, like there's the likelihood that someone's made like Minesweeper using this exact stack is impossible. So I just need enough of these that I can find like similar entities and go, okay, this is kind of like that, and I need to pull it out. That's basically what I did to get it working. And, it was cool. So I still haven't looked at all of these, but I'm excited to like test some of them out for sure. Yeah.
Is there like an ESLint plugin or anything to like that to make sure you're following the rules, or is that not really necessary for this?
I don't think it's necessary. The library, especially if you're doing it with TypeScript, will sort of give you a decent amount of hints that I found to make sure I'm on the right track. So like if I shape the state machine object incorrectly, it will very quickly tell me you can't do that. So a lot of it will boil down to on the enclosing objects, you can have states, contexts, actions, guards, and then like within certain aspects, you can have certain things. And yeah, I haven't really found a need for anything beyond like basic linting as of yet.
I just did a very quick Google search, and a ESLint plugin XState showed up. I don't know what it does. Like like a lot of things. I mean, Kirk has mentioned a lot of these phrases, but none of it means anything to me right now. Those ESLint plugins are like the kinds of things where, in my personal experience, help greatly once you are like rolling. But I almost feel like sometimes they get in the way early. I don't know if anybody else has had that experience. I'd be curious to see how people feel about that sort of thing.
Because they're yelling at you and you don't know why yet.
Right, and it's like, okay, maybe, or maybe not. And plus, this is not a first party, like the one I put in there. I'm not recommending it. It was just the first Google result, but not a first party thing, right? And so that's the other thing is now you're like on this person's like decision tree about how things should be, So I put it in there. I put it in there, Sean. If you, that's not, it was Sean, right? That asked that question.
Yeah.
Thanks. I put it in there if you want to check it out. Obviously, and there might be other ones too, but it's like there's not an official one, and so when there's not an official one provided, that's when I get a little, maybe
Sure.
maybe not, kind of vibe from things. So.
Well, yeah, this is actually one of the places where I think like I would pop in the Discord and I would like just ask like, hey, is this a thing that we use often or frequently? And usually like within like an hour, like I'll get a response from like one of the people who use this a lot. And they're like, yeah, I'd recommend that, or I'd recommend another one. You can go from there. But you did just remind me one last thing, which is sort of a thing I was hoping for, but I didn't really get. So with these application states, I was sort of hoping I modeled the app as like this, like this little union object, right? Like these things are not the same shape. So what I was kind of hoping is when I defined like state upgrades, it could understand like, oh, well, if you're going to active game, like active game has a grid. Like it just understands like, yeah, you're in that state. But like the way David explained it, providing those contexts, they're helpful on the usage side. Like on the React side, it will understand if like those fields exist in the different states. But here, it doesn't really. And most of the examples I've seen, they've really kept the context as like the same shape throughout the machine. So, things start undefined and then they get a value or they don't, which is typically a thing like I try to avoid. Like I don't want to have like an object that's like undefined until something happens. I just want it to like not exist until something happens. Like if I'm not in a game, I don't need like the concept of a grid, which is one of the things I like about TypeScript. But that's like a little hard to do. So like here we're doing like, hey, we're using like the if size is in context, well then I can use context.size and stuff like that, which is, it's not a big deal, but it's just like one of the things I was like specifically trying to check, because if that was true, then I would say like this is truly like completely bulletproof, because you could say at the top level, oh, in this state, only these things exist. And it just like understands, oh, if we're here or if we're trying to go here, that these things kind of have to happen. So I think like my second big project, I'm going to take a break from like side projects for a while. But my next side project is I want to see if I can do something like that in a language like F#. like try a version of this where with like a language that like thinks in types, and see if like if you just say this is the context, the machine just like knows, okay, if you're trying to go to this context, you have to give me an event that like provides the missing values, and I know those values are there. So that's
Yeah, that's been a pretty that like, and I'm not a super TypeScript person, but like that like what goes into context is one of the things that has like blocked me every time I've like started getting into XState a little bit, you know. So that's why I was curious about the side effects and you know how that relates to. That's pretty cool. Did anybody else have any you know, questions or insights, final thoughts?
Do you have a
XState
sense, Kirk,
sucks.
of how like is this pretty stable at this point? The language, the domain specific stuff.
The finite state portion is like as stable as it could be. That part's not changing,
Okay.
especially like the state chart like XML. That's not changing. The library itself, it feels like it's getting a lot of new features quickly. I am not sure if they're at the point where they're like, okay, no more breaking changes. Like we're going to maintain the way it is right now. But the feeling like, okay, I guess the ultimate answer is I would definitely be comfortable like using this in production for an application that I had to do. Like I there's enough people using it, and it has enough eyes on it that I would trust myself to use it for a project for sure.
Nice. And do you have a sense of like how heavy it is compared to like Redux in terms of dependency baggage, that kind of thing?
My sense is that it's less dependency heavy than Redux. One of the spaces I have not tested it on is just on like certain like high volume, like high performance issues. I know like, you know, Redux, the advantage of like Redux versus like just use reducer is Redux has like its own set of optimizations that it also does on top of that, you know. I am not sure how this handles like heavy amounts of like events happening at a particular time, or what happens if you have a sort of massive context that sort of needs working on yet. And yeah, that's the part where I'm still like kind of a novice in the community, and I'm just like listening to some of the more senior people say their experiences with it. But I mean, I don't know. The main thing I just see is like people just like it.
Yeah, and the just that's the fact that this is one of the key things for me is the fact that the state machine like concept is older than computers.
Yes.
You know, and so like that's one of those things that like really like calls to me as well, you know. Like the concept of like the design of the state machine itself, the like Kirk was saying, like dealing with React, and once you start like, okay, like if you have to do a ton of updates or if you have to have like huge chunks of state, you know, that's probably people have done those sort of performance reviews out there, but the like modeling the like paradigm of the state machine as this thing that somebody's like people have solved a long time ago. And it doesn't have anything to do with flux or like things that are like 6 years old at most or whatever, you know what I mean? Like that like idea is so it's very cool to me. This is why I was very excited about this talk, and you know, everything is.
I definitely like that too. That's, you know, that's what I like about functional programming as well. And like even, you know, SQL, like when something like, math is complicated and hard to understand, but when a programming thing has a solid like theoretical or mathematical foundation, it's nice because, you know, it's gonna stand the test of time.
Yeah.
There's
Like
a really cool story about
good,
that.
Oh, sorry, Kirk, you go ahead.
I was just gonna say like, so somebody like in the 50s had written up a state chart for a watch that he'd owned, Like he just like done the entire thing. He's written it all out. Like this is how the watch works. And I think like a couple of years ago, someone just like took his original thing, like the original document. He's like, I'm gonna make this, and he just like made it in JavaScript, and like it just is all of it. Like it just cool. Like this still works because like we figured it out like a long time ago, and this is fine. And I thought that was pretty cool. You know, like I don't know, that feels like a good endorsement for like, at least is the premise of this of some type of soundness.
Yeah. I was just going to say, I feel like really confident using React in production, for instance.
Yes.
Because it's been around for so long in my head. I mean, and so it's been around. I just did Google this just to make sure I got it right. But 2011 was when it was like first, and this was like
10
old,
years.
but like 10 years, you know what I mean? But that's like really like that's a long-standing front end library, you know. And state machines are just like 56 years old. You know what I mean? It's just I don't know. It's cool. Like the whole idea of this like math-based thing that actually works.
What I like is that it's math-based, but it's not like equation-based, right? Which
right.
is
You don't have to like do math to do it.
yes, which is very important to me actually, and like especially if I'm like teaching people. If I tell I don't have to like, hey, you want to take this cool math? Like, no, I don't. Like, I'm not a mathematician, and a lot of people like don't like that type of math. But I feel like stuff like this, where okay, we're starting here to here to here. It's like that's approachable, and like I can talk about that with somebody, and I can walk through that with somebody. Versus if you go to the Wikipedia definition of finite state machines, why does Wikipedia do that? Like any topic, even tangential to math, Wikipedia is like, hey, you want to see all these equations? Look at how smart I am. And it's just like, no. As somebody who likes math, I'm still like, no, I don't. This is not what I wanted. Yeah, well, I think it's cool.
Yeah, and I feel like the big piece of that is the visualizer, right? Because it's not like and this is when you find yourself like doing math, you know, I always feel like I'm too at too low of a level of where I want to be if I'm making a website, making a web app for somebody, or writing some sort of program, and the state machines and XState like are like this kind of really cool intersection of that, right? Because you know,
I think
we're not having to like write a lot of stuff, but you can visualize it. But you're visualizing the thing that is this situation that has existed for a long time. You know, I don't know, it's neat.
Like I think like why is React powerful? Like, or what makes a framework or a programming language powerful? And like that's about like sensible abstractions. You provide something that people feel like empowered, like there's an easy way for them to translate their thoughts and their ideas into something tangible, right? React hits that really well because you know like what React does under the hood, like that diffing algorithm, that's not a thing that's like particularly approachable. That's actually very, very hard to do. And doing that yourself is a huge pain in the ass. So I'm super happy like React does that and says, hey, just say what things are and I will handle how they like interact with each other. And XState is, I think, I'm not sure if it was Ian or Sean pointed out earlier, you know, like XState is like say what the application is, and I will handle making sure that you're always going to like the places that you said. And that's like what sensible abstractions feel like they should be, right?
Yeah, it's good stuff.
That thing was because I was right.
Exactly. Full time.
Yeah, so I mean, if anybody wants to learn any more about this or just like wants to hear me talk some more, I think Dan provided all my info. You can totally reach out. I'm gonna keep using this library because I actually really like it. Out of all the state management things I've tried in the JS ecosystem so far, I like this one. Mind you, I still just like use Reducer, but you know, when things get a little more hairy, I think XState is the next place I'm going to go, and hopefully, if I ever do this again, I can have a little more knowledge on like some of the questions that people ask for sure.
Yeah, and I was just going to drop in one little excuse me, one other little extra piece is that you can use the state machine sort of idea without even using any of these libraries if you wanted to. If you visualize some of this stuff, and you won't get all of the nice stuff, you won't get context, whatever, but starting to think this way will actually help your React components, even if you don't mess with XState at all, right? Because I put in this, I don't know if anybody saw the tweet I tweeted about this thing, but lots of times with React components, you end up having this thing where you're like, okay, you have, oh yes, is loading and is stale, and okay, is this error or something, and all these different like flags basically, and you have to check for all of them all the time. And instead of doing that, you have a state situation where the state is just the one thing,
Yes.
and you can do, if it's very, very simple, you can do it by yourself without any sort of like extra big baggage or whatever. And you can use reducer to do it, or you can even use state and like a use effect to manage it. But like this, there's the configuring your state and what happens with the side effects and all that stuff can get complicated. But if you think like a state machine, think like that sort of approach, it can make your components that consume the state much more simple. Because instead of like checking for 700 different things in different combinations, you're just like, okay, this thing right now is idle. This thing right now is loading, and it can make your life a lot better. If you've seen the Reach UI libraries, that they were started by the React training guys, and now I don't think that they're in charge of them anymore, but they do some of that stuff for like their tooltips. For instance, the tooltip component, really cool source read if you want to learn some cool UI stuff. The way they wrote their tooltip thing, and it's all in one file, and there's no XState and nothing like that, but it's neat. It's a cool approach. And
Ooh, can I show you one more thing?
Absolutely.
Cool. One more, maybe related or not. Work faster. This is the part where my computer's like, so you just opened up all these code sandboxes. Thought that was smart. Smart. But yeah, related to what you were just saying. So this is what I used to do like before XState, when I just was obsessed with useReducer. I'm still obsessed with useReducer. I love useReducer because like I came from Elm, and Elm is useReducer. But yeah, so it's a similar thing like what Dan said. When I am doing any application, front end or back end, I'm just like, okay, like what is the minimum thing that I need like to do this? Like what my state is, like what are the shapes that I need to like do the things I need to do? And whenever some action occurs, I'm like, okay, well, again, like what is the shape that this needs to be? And like what is, so like this type value is very similar to like event payload. And these are also like similar to like what is the state and what is the context. So I will, before I write any functions, I just sit and I might pen and paper this, or maybe just like a little like IDE open, and I will write down what I think my application's domain is. Like what is the data that matters, and what do I want to do with it? What are the transforms that need to happen? So by the time I get to my reducer, like I already have this language of what my application is, and the functions are just like transformations from like what I've already said can occur. So here I tend to prefer switch statements, because like if I've already defined the only things that can exist, you don't have like hanging defaults on switch statements, and you can just be like declarative in, well, what is the type of the action and what am I returning? And I know like all these things returned have to be like these shapes that I've defined. And what I like about TypeScript is you can turn basically strings into like concrete types. So this type input updated, like this has to be input updated, and this has to be like this. These things have to exist. Like I can't even spell them wrong, because like TypeScript will be like, that's not true. that's not what you said. So I spend a lot of my time like thinking about the shapes of things. Once I have all the shapes for my application, the functions are just like a consequence of those shapes. So there's this part, which, and I don't know, once you get like practice at it, then like, where do I insert an effect becomes like easy to visualize. It's like, oh, I need some context that I can't like define or just like make in a function. This is where the effect kind of kicks in. As soon as I get it, I need to turn it back into a shape that is relevant to my app. The little controller object here, I went like, this is probably too far. I was like, this was for a take home for a company. So I was like, okay, we can like style out that this is basically a game controller object for a WebSocket. So I'm like, okay, I don't want this to just like define 4 buttons. I want it to really make it so that like it has to be 4 separate buttons, and like it is literally impossible for you to accidentally pass the wrong button. And like there are 2 sticks, and they have to be like the 2 right sticks. And this might be a little overkill, but like you've made this documentation in code for what your application is. And when you come back later, there's always context for what's going on. So this just exposes this parse JSON, and I just try and get the appropriate values. And if I don't get them, it throws an error. But if I have the appropriate things, they're all in the right shapes. And then I get to say like, hey, give me the A button instead of like, give me a button and then see if the name field is A. You know, it's, and you can do this type of composition to make like really powerful and expressive libraries. And it's just the same like React, like you're declarative, you know, these are what things are versus like, this is what like to do. And the application just like follows from that. So once I say, oh, this function takes a controller, I know for sure it's going to have these 4 buttons. It's going to have these 2 sticks. They're going to have different names. And it's going to be like a good thing. Yeah. Okay, I swear that's the last thing I'm going to say.
I mean, all of that. I don't know. I always like seeing all this kind of stuff. Does anybody have any final thoughts, final questions before we wrap up? If not, I think we will call it a night. I just want to say thank you very much to Kirk again. I thought this was great. I mean, if you couldn't tell, I was very pumped about this talk. Very pumped about state machines in general and XState and all that stuff. And I, as usual, pretty much just forced Kirk to come and talk is how I have been getting most of the Cleveland React talks, are people that just pretty much, you know, either tricked or otherwise.
You genuinely did. You just asked like, hey, does anyone want to do this? And then I was like, yeah, I'll do it. And then I was like, okay, I gotta learn XState.
See, I don't want to talk about my secrets, you know, of getting people to come and talk. But anyway, I very much appreciate it, and I thought this is very great. Again, if anybody has anything that either they would like to talk about or would like to hear about, and we probably could find or force somebody to come and talk about it, please let me know, or let us know, you know, in the Slack or on Twitter, or on Meetup comments. I will post the links. I don't know if Kirk, if you feel like sharing the slides, but if you do, we can post the link to the slides, and I'll get the video up on YouTube in the next couple of days as well. And I'll post that on Twitter and on the Meetup like comments for the event. So if you want to come back and check that out anytime. And other than that, I will wish everybody a good night, and we'll catch you next time. All right. Thanks, everybody.
Bye.